Hi, this is the second video of Finchley College series of videos on principles of surveying, and one of the major parts of surveying is mathematics of surveying. How does maths come into surveying and setting out? Now the mathematics is nowadays done by the total station. So if I put a total station here, I'm not going to turn it on, I'm going to do anything, but what the total station does, it does the maths for you. So therefore you don't need to know maths anymore. Well, you need to know it, but you don't need to apply it, you don't need to do any calculations. What you really need to understand from this is that mathematics is simple Pythagoras theorem. But let's understand first of all the coordinate system. How does the coordinate system apply? There are two coordinate systems, the Cartesian system, which you call a rectangular, or the polar system. So in the Cartesian or rectangular, we have two axes at 90 degrees. So this is 90 degrees, okay? This is a east axis and this is a north axis. We say plus north, minus north, plus east, minus east. We don't have south or west. The coordinate system works in fact, for example, the units are in meters. This is the intersection, is the origin. And the coordinate for origin is easting 0, northing 0, and height 0. Now, this axis is on the floor, it's on the plan. So it's actually, I can be standing here. It's not vertical, it's on the floor. So if I was happen to be standing here, say, my easting will be, if I draw a right angle to the east axis and I measure to the origin, my easting in this case 3.7 meters. My easting is 3.7 meters. And my northing, if I draw a right angle to the north, my northing is say 3 meters. It's plus because I'm reading on plus and plus. We don't usually write plus, but the coordinate is easting is plus 3.7 meters and the northing is plus 3 meters. So what the coordinate tells us is that where we are in relation to the origin, in relation to the axis. If I was here, for example, if a point was here, I will draw vertical to both axes. My easting will be again 3.7 meters plus, but my northing is now minus. Northing is minus 1.8 meters. If I was here, for example, if I draw vertical, my easting will be minus 2 meters, and my northing is plus 3.5. So the coordinates is simply you draw a right angle to the axes, and what the coordinate is telling you how far you are this way or this way along the axis, how far you are forward or backwards from the origin. The coordinates is telling you where you are. The important things about the coordinates is that the relationship between them. For example, if I look at these two, this one, the easting is 3.7, this one is easting minus 2. So this one is, you add them, 5.7 meters more to the right of this one. The northing is 3.5, northing 3, so the northing is half a meter forward. So for example, if I draw a line like this distance is 5.7 meters, this distance is 0.5 meters. So what we are telling, if I was here, this point is 5 meters, 7 points to my left and half a meter forward. If I was here, comparing that, this point is 5.7 to my right and half a meter behind me. The coordinates is that if we subtract a second from the first, we get the correct sign. If I subtract this from this, I'll get that that's plus, and northing is minus. This point is this much to my right and this much below. So the coordinates will tell us where everything is in relation to this system, and also what they are, how far they are from each other. And it is simple mathematics, a calculation of adding and subtracting one coordinate from the other. what we do in here, we look at the difference in easting. This is the Greek symbol for difference. So difference in easting is the easting of 0.2 minus easting of 0.1. And the difference in northing is the northing of 0.2 minus northing of 0.1. So to calculate the difference between one point and the other, we subtract the second point easting from the first point, second point northing from the first point, and we calculate the difference in easting and difference in northing. And that's all you have to do. In this situation, we have the coordinates. We know the position. We have easting, northing. We have easting, northing. So on a construction drawing, you get your drawing and you work out coordinates for various points on the drawing. And then you subtract one from the other, and that will tell you how far they are in relation to each other. Now, that is all we need for the Pythagoras. Pythagoras, what they calculated, that if the instrument in surveying is always set up here at point number 1, this is my total station. My total station is set up at point number 1. This is the point I want to set out or I want to survey. So we look at the setting out first, and then we look at the surveying. When you want to set out, you have the coordinate for the instrument, you know where you set up, and you want to set out the point, you know the coordinate you want to set out. Let's say the coordinate for here, easting, say 300 meters, and the northing is, say, 650 meters. In this point, the easting is 303 meters, and the northing is 654 meters. So this point is 3 meters to the right, because the easting of this is 3 meters more than that, and the northing is 4 meters further forward, because its northing is 4 meters more. Therefore, the difference in easting is 3, difference in northing is 4. That's all we do. We simply need to subtract the coordinate of the second from the first. We calculate. If this point was over here, second minus the first will be negative. Therefore, in this case, the point will be here. This is the point 2, this is the point 1. This will be negative and this will be positive. Now, to calculate distance, you have this formula. Distance is the square root of difference in easting squared plus difference in northing squared. In this case, it will be 3 squared plus 4 squared equals to 5 squared. So the distance is 3 squared plus 4 squared, which is 25. The square root of 25 is 5. Therefore, the distance is 5. Now, the instrument does all of this automatically. As soon as you say, this is where I'm set up, you will do that from the resection program. You do a resection program, which means you cite 2 known points. You measure to one, you measure to the other one. It will calculate its position. Then you will go to the memory, and you select the point you set out. You select this point, number 2, and the instrument in an instant, it will subtract that from itself. It will subtract the difference in easting and difference in northing. It will calculate the distance. Then what it does, it calculates this angle alpha. The angle alpha is the key. This angle will, if this is the north direction, this is plus north. So the instrument will draw the north from where it is and says, this is the north direction. Is this to my right? Is this to my left? Is this in front or there? Like this. The instrument is set up here. In this situation, in quadrant 1, the point is to your right and in front of you. The instrument will calculate difference in easting, and you will see is plus, because that minus that is more. This is higher easting, this is less easting, therefore is plus. The northing for this is more than the northing for this, therefore the difference in northing is plus. So then it says this is plus, this point must be to my right in front of me. If the point was here, then the northing for this one, the easting for this one is plus because it's more than this. This is the instrument, always, number 1. The easting is more, therefore difference in easting is plus. Difference in northing is minus because this is further behind. The northing for this is less than that. So he says this point is to my right and this point is behind me. when it calculates the coordinate for this from itself, if difference in easting happens to be minus, because this easting is less than that, and this northing is less, so therefore, if difference in easting is minus, difference in northing is minus, is telling me the point is behind me to my left. In this situation, the point is in front to his left. When it subtracts this coordinate from itself, difference in easting is minus, difference in northing is plus. Then he uses this table. It says, if the difference in easting is plus, if the difference in northing is plus, the angle alpha will be the bearing. What's bearing? Whole circle bearing is this angle from the north to the line. In this case, the angle alpha and the bearing are the same thing. We call this whole circle bearing. Whole circle bearing. And we write it as WCB for short. So the WCB is the same as alpha because you both from there to the line. In this case, we need add nothing because the angle and the bearing are the same. Therefore, we need to add nothing to the alpha. The key thing in here is to find the bearing. What is the bearing? The bearing will tell the instrument what angle it needs to turn from the north to get to the point he wants to set out. Is it here? Is it here? Is it here? Or is it here? So to calculate, is calculated the alpha. The alpha is always this angle. The alpha is always the internal angle in this triangle, but it needs to calculate the bearing. So in this situation, it says difference in easting was plus, difference in northing was minus, therefore I need to add 180 to my alpha. This is the alpha. This alpha is negative because one of these was negative, difference in northing was negative. Therefore, it will say the angle alpha, whatever it is, I need to add 180. This is 180 minus that. If the point happened to be here, it says, okay, this is my alpha I calculated. The whole circle bearing is this angle. This angle is alpha plus 180. Therefore, I add 180. In this case, it says the point is in front of me to my left. This is the alpha is negative because the easting was negative. Therefore, I need to add 360 minus that. Therefore, I need to add 360. So what the total station does, you don't need to do this yourself. The total station does it automatically. Once the total station subtracts the coordinate of the second point from the first point, it will immediately look, is it plus plus, plus minus, minus minus, or minus plus, and it will add these to the angle it will calculate. Now, what is this angle? This angle will use the Pythagoras. Sine of this angle is the length opposite over hypotenuse. So if that was 3, that was 5, sine of alpha will be 3 over 5. Cos of alpha is the length adjacent over hypotenuse. In this case, it's 4 over 5. Tan of alpha is opposite over adjacent, which is 3 over 4. We always use the tan. Tan is the key. Why? Because we don't need to know the distance. We already calculated difference in easting. We've already calculated difference in northing. So why should we use this? We use this. Tan of alpha is 3 over 4. But sine, cos, and tan are simply ratios of one length to another length. Sine, cos, and tan do not have units. There is no unit because length over length, they cancel each other out. 3 over 5 is unitless. Now to calculate the alpha itself, what is the alpha? You need to use the arc sign, which is shift sign on the calculator, shift cos on the calculator, or shift tan on the calculator. So you go shift tan 3 over 4, and it will give you shift tan 3 over 4 is 36 degrees 0.869 in decimals, or 36.5212. So that is how the calculator or total station calculates alpha. Alpha is always arctan opposite over adjacent, difference in easting over difference in northing. This is what we calculate automatically. The instrument calculates that, immediately calculates the distance, difference in easting squared, difference in nosing squared is the distance. Then he goes to alpha, he says alpha is shift tan, this is the key. Alpha is shift tan, opposite, difference in easting over difference in nosing, he calculates alpha. Once he calculates alpha, he'll look at the sign for difference in easting and difference in nosing. If it's plus plus, and he add nothing. If difference in easting plus, but difference in nosing is minus, is over here, I need to add 180 to alpha to calculate whole circle bearing. If they're both negative like this, if that's negative, is to my left behind me, I need to add 180 to the alpha. If the difference in easting is minus, difference in nosing plus, I need to add 360 to the alpha. So, whole circle bearing is alpha plus x. X is that. This is x. X is a constant, and x depends on the difference in easting sign. You use this formula. Alpha is arctan, difference in easting nosing. WCB is alpha plus x. So, it may seem a bit confusing at the beginning, but it's really simply forward, it's straightforward. You know where the instrument knows where it is. You give it a coordinate, I want to set out this. It will subtract that from itself. It will calculate difference in easting, difference in nosing, immediately calculate distance, immediately calculate arctan, calculates the angle. It will look at the sign of this, is it plus or minus, what do I need to add to it, and it will display WCB is x, like this, 3652. It does that in less than 1 second. If you are going to do it, it might take you 2 minutes. 1 minute, 2 minutes to do. But the totalization does it in 1 second. You don't need to do any maths. That is the job of totalization. The original totalizations that we had 30 years ago, 40 years ago, or Theodoras we had, they couldn't do the maths. Now, because of the advent of better memory chips and powerful instruments, they've got the maths automatically on board. Essentially what they have on board is a 5-pound calculator. It's got a 5-pound calculator on board. That's all it has. Whether you buy a totalization for £1,000, £2,000, 5,000 or 50,000 pounds, it's got a 5-pound calculator on board. It does square root, shift root, difference in easting square, nosing square, calculates distance, shift tan, opposite over adjacent, and then it will add that. It makes no difference whether you buy a £1,000 totalization or 50,000. They do the same thing all day long. The job of totalization is one thing and one thing only. Calculate bearing, calculate distance. For setting out, I want to set out this point. What angle do I need to turn and what distance is it from me? The instrument will do it and it will show you the bearing and distance. Then, at this point, what happens? Let's say at this point, I'm here. The instrument is pointing here at the moment and he wants to set out this point here. The instrument knows the bearing on the screen, for example, is 300 degrees. It's calculated this bearing, for example, 50 degrees. And it will calculate this difference from where it is now to where it should be. It says to you 300 to 360 is 60, plus 50 is 110. Turn me plus 110 degrees. So as you start turning it to the right, plus means the right, minus means left. As you turn towards that, this gets less, less, less. When this becomes 0 degrees, you are pointing in the right direction. So you don't even need to know what is the bearing. You don't need to know that. All you see in here, it says difference in HZ is plus 110. Turn me 110, plus means to the right. Turn me 110 degrees to the right. And as you turn right, this gets less and less and less and less. And when this becomes 0 degrees, you're pointing in the right direction. Then the instrument using this formula has calculated distance, in this case 5 meters. If your measuring to a point is 5.8 meters, it says come down to me 0.8. If you're short, like here, you're measuring say 4 meters, he says go away by 1 meter. When the difference between what you are measuring and what you should be measuring is 0, i.e. difference in distance is 0, that point is where you want to set out. So what you're looking for is a 0 in angle and 0 in distance. You don't need to know what the distance should be. You don't need to know what the bearing should be. You don't need to know what the angle should be. You don't need to know anything. All you say to it, I want to set out this point, immediately say, turn me this angle to the right. You turn the angle, you press distance, and then it says to you, come down to me or go away. And when this is 0, difference in distance 0, you mark it on the ground. So the mathematics of surveying is how the totalization works. It works simply Pythagoras. Pythagoras is a simple mathematics that you did in a GCSE, and maybe you didn't understand what you were doing it for, but surveying and setting out and engineering is simple Pythagoras, nothing else. You don't need to know anything else in mathematics. You don't need to know differentiation, integration, probability theory, statistics. Forget about any of them. You don't need them. You are wasting your time by studying at university. If you went to university, you're totally wasting your time. This is all you need for setting out a survey. If you know, you don't even need to know that because it tells you, look, turn me this amount, measure me this amount. You turn the instrument. When the difference in HZ is 0, press the distance. When the difference in distance is 0, you say it's summed up and your assistant marks the point. That's all they're paying you for. They don't pay you to know any of this. You just do a resection. Where am I? What am I want to set out? This is the point. Select the point from the memory. As you select through different points, these change immediately. As you go through point 2, point 3, point 4, these will change immediately, and you change, turn more or left. If the difference in Z was minus, means turn me left. It shows you the shortest and quickest route to get to the point. It says, if this point here, turn me minus. If this point was here, it would say turn minus. If it's on your right, says plus. It doesn't matter, you can always turn right. I personally always turn clockwise, is my habit. It doesn't matter, because I'll eventually get to 0, whichever way I go. You need to make sure the bubble is level, the instrument is set up properly and is level, and you do your resection, which starts to 2 known points. Work out where you are, select the point you want to set up a memory, and that's it. And then you turn it to the angle. And that is simply, it may look a bit complicated here on this small board, but it's simply, on the instrument, you do resection, you go to stakeout program, you select the point to be stakeout, immediately shows you what to turn, what the distance, you turn it. Once you're there, you go to fine motion, get it nearly there. This one turns it slightly to your right, this one turns it slightly up and down. You can move it by hand, but when you're nearly there, you can use it fine motion. And when you are, the angle is 0, you press distance, and when the distance is 0, you mark it. So Pythagoras is all we need to know, and understanding the coordinate system. Now the next one was the polar. What is the polar system? This was all rectangular. The polar system was this one. The polar system was this one. It was telling you, turn me that amount and measure that distance. This is the polar system. So the equipment responds to you in polar. You give the coordinates in rectangular. You say the coordinate I want to set out is easting 303, northing 654. The instrument responds to you in polar. It says, turn me 110 degrees right and measure 5 meters. That is the polar. That's all it is. Polar is used for response to setting out, survey. And when you do surveying, you're using polar. So what are we doing in surveying? In surveying, the instrument is set up here. You're sighting to a point. You want to know what is the coordinate. We don't know its coordinate. What is its coordinate? The instrument, as you point to it, it can read the bearing itself on the screen. For example, 36, 52, 12. You press distance, it measures the distance, for example, 5 meters, and immediately uses this formula. Now, let me show you this formula, how the formula for polar works. I'm going to take these off here. And I'm going to take a little bit off here. This formula was sine of alpha, opposite over hypotenuse, difference in easting over distance. I can write a formula based on this one. Difference in easting is sine of alpha times distance. And difference in northing is cos of alpha times distance. Now, in this case, sine of alpha and sine of bearing are the same. Cos of alpha and cos of bearing are always the same because they add to 180. They are multiples of 180. Therefore, I'm going to change this alpha and I'm going to write WCB. I'm going to write sine of WCB because WCB and alpha, sine and cos are the same. So, as the instrument turns to a point, it reads the bearing on the screen and it says sine of this bearing times this distance is the difference in easting. Cos of the bearing times this distance is the difference in northing. It will add it to its own easting and northing and it will display the coordinates of the point on the screen. So it says, are you starting to that? As soon as you press measure or distance, it will display the coordinate of this point on the screen. How does it do it? It reads the bearing on the screen, it says sine of bearing, and as you press distance, it measures the distance. Sine of bearing times distance is difference in easting. Cos of bearing times distance is difference in northing. Easting of point 2 is equals to easting of point 1 plus difference in easting. Northing of point 2 is northing of point 1 plus difference in northing. So, easting of 1, northing 1 is the instrument coordinates. It knows its own coordinate. And simply, it would add difference in easting, which is sine of bearing something to itself, and it will display that. N2 is the northing of 2, E2 is the easting of 2. If you sight to another point here, it will calculate the bearing, sine of bearing times distance, difference in easting, difference in northing, and it will display the coordinate. So, Pythagoras Cartesian system is coordinates where you are in relation to the axis. Polar is what angle have I turned? What angle have I turned? In this case, what angle have I turned? What's the bearing? WCB times distance. I can identify this point by its Cartesian coordinates, easting and northing, or by angle from the north and distance from one point to this one. So we can pinpoint a point either by its coordinate or by its bearing and distance from another point. And that is all the mathematics of surveying. Mathematics of surveying is difference in easting is sine of bearing times distance. Difference in easting between any 2 points is the bearing. And what's the bearing? As I say, the bearing is this. If I'm here, if the point is here, the bearing is an angle from the north to the line. If the point was here, the bearing is the angle from the north to the line. This is the bearing. If the point was here, the angle was from the north to the line. As you turn the instrument, it will measure the bearing. It knows the bearing. So when you press distance, it does sine of that bearing on the screen times distance is difference in easting. Add it to its own to calculate the destination. I hope you enjoyed this lecture about principles of surveying and Cartesian and polar system, mathematics of surveying. You can do this yourself at home. You can put different values in here. You can ignore that. You can put different values in here or put a coordinate, calculate difference in northing and use this formula, calculate the bearing, and then from bearing and distance, double check the distance. Thank you very much. Thanks for watching, and I hope you come back.